Welcome everyone to a We Hack Purple stream. I'm Tanya Janka, your host, and Amanda's also helping me host. But today we have a special guest and her name's Rana. She's my friend. She's ridiculously awesome, and I'm so happy she said yes to being on our stream. And so you might notice I've tweeted about her a lot, so she's finally here. I'm really excited. And with this, Rana, please take it away.
Hi, everyone. Thanks for having me, Tanya. I'm very excited to be here as well because for those that don't know, Tanya was actually my mentor when I first started out. She used to live in Ottawa, doesn't live anymore, which really sucks. But I'm really excited to actually be on, a show that she had started. And so I'll start off by sharing my screen. All right. Let me know if you could see my screen properly.
It looks great.
Awesome. All right. Again, I don't have visibility on the chat, and so feel free to stop me, Tanya, whenever anyone has any questions. And let me just remove this speaker tab so that I could see the slides myself. All right. Okay. So again, thank you for taking the time to attend my presentation. I'll start off by introducing myself. So my name is Rana Khalil. I have a bachelor's and a master's degree in mathematics and computer science. I've been fortunate enough to work in several areas in software engineering, including quality assurance and software development. I made the switch to security about 5 years ago, and now I currently work as an application security engineer consultant at an organization called C3SA. So for those of you that are not aware what an application security engineer does, essentially my responsibilities could be divided into three. The first one is testing any third-party applications or in-house built applications that our clients use. The second one is integrating security as part of the software development lifecycle. So that's something that we're going to talk about today. So instead of finding vulnerabilities, let's say later in the SDLC, what we do is we integrate security as part of earlier in the SDLC, so as part of every phase, so that this way it significantly cuts the effort, the time, and the cost that is required to fix those vulnerabilities. And then the third responsibility is essentially developer education. So you could see over here on the slides, I have an academy. I also have a YouTube channel and a blog where I teach web application pen testing. And I also do in-person training teaching developers how to code securely. So that's pretty much it. Enough about me. Let's dive into the presentation. So whenever I learn about a new topic, and if you've attended one of my previous presentations, they almost always start this way. So when I learn about a new topic, I always ask myself three questions: the what, the why, and the how. If I can answer these three questions within the context of the topic that I'm learning, that means I have a basic, solid understanding of that topic. And so for our topic today, we're talking about securing open source dependencies. So the questions that we're going to be talking about are: one, what are open source dependencies? Two, why should dependencies be managed? And three, how can these dependencies be secured? My aim for today is to have everyone in the audience be able to answer these three questions by the end of the presentation. And you'll see the whole presentation is based on these three questions, and then we'll also loop back to answering these three questions at the end of the presentation. All right, so we'll begin with our first question, which is: what are open source dependencies? Now, you'll notice I have a ton of diagrams in my presentation, and they're all references to how the real world works. So pay attention to the diagrams. And this is the first one. So you could see over here, you've got all the modern digital infrastructure at the top, and it's all built on open source projects developed by people around the world. Now, As we go along in this presentation, you'll understand how fragile this ecosystem can be and the issues that result from having an ecosystem such as this one. I feel like people tend to underestimate the type of issues that can result from this type of system just because they don't really properly understand how big of a problem it can be. And so what we're going to do is first we're going to set the context to understand the scale of this problem, and then we'll talk about tools that have been developed specifically to address this problem from a security perspective. All right, to set the context, I borrowed a few slides from this amazing talk that was given at the Hack in the Box security conference. It was titled Finding Vulnerabilities and Malware in Open Source Code at Scale, and it was done by Mark Curfew. I've got the name of the talk on the screen. The talk essentially focuses on how in the future, instead of ransomwaring desktops, the future is going to move to ransomwaring web applications, and that's done by introducing malicious code in open source libraries that major frameworks use on the internet. It's an interesting and really scary talk because they actually have a demo in that talk. I definitely recommend watching it. But to get back to our topic, which relates to this talk, the talk really starts off by essentially discussing how people consume open source software, and it likens it to the making of a code cocktail. So, or essentially making a cocktail. So the first thing that you do is choose a framework for the application that you're developing. So let's say if you're developing an application in Java, then maybe you're using the Spring framework. If you're developing an application in Ruby, then maybe you're using Ruby on Rails. Or for Python, maybe you're using Django or Flask or so on. But the idea is that the framework that you're using is open source, which makes the basis of your entire project open source code. And then you want your application to have custom functionality or custom features that allow you to sell your application. And so you write your own custom code to add that functionality. But then you realize, well, I want other functionality in my application that other people have already implemented. Let's say being able to log in using Facebook, or being able to log in using other social media accounts, or let's say being able to pay through PayPal and so on. So why make your life harder and reinvent the wheel by writing that code yourself? So what you do is you actually import open source libraries that solve the problem that you're trying to solve, or that implement the functionality that you're looking for. And so what ends up happening is you essentially have a cocktail of code where 90% of your code is open source code and only 10% is custom code. And that's a significant ratio because while organizations spend considerable time and effort ensuring that that 10% custom code is properly secure, usually little to no consideration is put into ensuring that the open source code, which makes up 90% of your applications, is actually secure. Now, you might be thinking, for the developers in the audience, you might be thinking, well, I'm not sure that's true. I'm looking at my code base and I'm definitely only importing, let's say, 3 open source libraries. And there's no way that can be 90% of my code. And I actually get that comment a lot. And so my answer to that is usually, while it might seem to you that you're only importing 3 open source libraries, you're likely using much, much more than that. So what happens when you're requesting a library, let's see, this is the library that you directly request in your code. What happens is this library says, wait a minute, I need this library to survive. And so it pulls it down. And then this library says, well, wait a minute, I need this library to survive. And so it pulls it down. And then this library says, well, wait a minute, I need this library to survive. And so it pulls it down, and so on. And so what you end up with is essentially, let's say, 100 libraries instead of the 3 libraries that you directly imported. So the ones that you directly import are the ones in green. So these are called direct dependencies. The ones that your direct dependencies rely on are called indirect or transitive dependencies. And those are the ones that are in gray. Now, so you end up essentially with like an interconnected graph of dependencies that becomes really difficult to manage manually. A really simple example that I like to use to better understand this concept is, imagine you invite 3 people to your house that you absolutely trust. Now you really trust those people, and that's why you're giving them the address to your house and letting them in. But then those 3 people end up inviting 3 other people. And then those 3 other people end up inviting 3 other people. And then those 3 people end up inviting 3 other people, and so on. And so instead of 3 people showing up to your house, you end up with 100 people at your house. And out of those 100 people, maybe one of them is malicious and ends up trashing your house. And so that's essentially kind of how libraries work. If there is issues, so security issues or what we call vulnerabilities, in any one of the indirect dependencies, it could trickle up to the direct dependencies and eventually make your application also vulnerable. And so we'll talk about that in the next section. All right, now to understand how open source code makes up a large portion of the modern digital infrastructure from a real world perspective, let's look at a few statistics. So Synopsys does a study every year where they do essentially an in-depth analysis or a study of the current state of open source security, compliance, licensing, and code quality risks in commercial software. And the results are all summarized in a report called the Open Source Security Risk Analysis Report, or in short, OSSRA. And the link to the report is on the slides if you're interested in reading it. So essentially what they did is they examined over 2,400 commercial code bases across 17 industries, including financial and healthcare. And they reported out of the 2,400 code bases, 97% of them contained open source code. So what that means is that almost all the code bases contained some form of open source code. And then when they looked at each individual code base, they found out that for each individual code base, 78% of the code is open source code. And that's a significant number. So approximately 80% of each application was made up of open source dependencies, and only 20% was actually custom code. Now, again, this type of ratio can have significant compliance, privacy, and security related implications. And that leads us to the next question that we would like to answer, which is, why should open source dependencies be managed? Now, we briefly touched upon that in the past couple of slides from a security and a privacy perspective, but there's also a functional and a licensing perspective that we will touch upon. Now, to highlight the scale of this problem from a functional perspective, there's nothing better than using real-world incidents that happened. So a few years ago, a developer got really upset that one of his NPM modules was taken down due to a copyright infringement. And so what he ended up doing is, instead of just taking down that one library, he ended up unpublishing over 250 of the libraries that he developed for NPM and he had put on NPM. And one of these modules was called the left pad module, or left pad library. And it was literally just 11 lines of code, and all it did was pad something to the left. Now, this might seem like not an issue that he took down this 11 lines of code, which are on the screen. However, this ended up causing a ripple effect that took down majority of the applications worldwide that were built in JavaScript. So you had developers waking up to broken builds and failed deployments just because someone took down 11 lines of code from the NPM repository. And the reason was because this library was embedded in a major framework called the Express framework, which is used to build Node.js applications. And so the builds for majority of the applications that were built using that framework ended up failing because they couldn't pull down that library, which is quite insane if you really think about it. And it goes back to showing how fragile this type of ecosystem can be. Now, of course, after this incident, NPM put certain restrictions on who can unpublish libraries, and it essentially, there's a ton of restrictions right now, but essentially the bottom line is if a library has any dependencies on it, you're not allowed to unpublish it. But you could see the type of issues that really could result from this type of ecosystem. But again, this is from a functional perspective. We're here to kind of talk about security and privacy. And so how does it affect the security and privacy of applications? Well, let's talk about a really famous breach that occurred a few years ago. I'm sure everyone in the audience has heard about this breach. So it was called the Equifax breach, and it was where the personally identifiable information, so the PII information of hundreds of millions of users in the US and Canada were stolen. Now, the reason that breach occurred was because Equifax was using the Apache Struts framework. And at the time, the version of Apache Struts that they were using was vulnerable to a remote code execution vulnerability. Now, they did know about it, so they were informed that they were using a vulnerable version. However, they didn't patch it in time. And so what ended up happening is they ended up getting breached. And the scary thing about all this is that these are all article headings or titles, sorry. And you could see over here one of the articles that came out during that time was that the code responsible for the Equifax breach was downloaded 21 million times last year. So the year before the breach had occurred, the code that was responsible for the breach was downloaded 21 million times, which is insane. And this one is even worse. Most of the Fortune 100 still use the flawed software that led to the Equifax breach. And so even after the breach had occurred and made worldwide news, they evaluated the Fortune 100 and they saw that they're still using the same vulnerable software that allowed Equifax to be breached, which is insane. A more recent example, again, which I'm sure everyone is aware of, is the Log4j vulnerability that was released in December of last year. It affected millions of devices worldwide. I remember last year when I saw someone post about this on Twitter before it was picked up by the media. I remember thinking, oh my God, we're screwed because Log4j is integrated in millions of Java-based software and servers worldwide. And like the exploitation of this vulnerability, which was really simple to exploit, not only could lead to remote code execution, but essentially you could use the remote code execution vulnerability to install malware and other backdoors in networks that you infiltrated. And so when this came out, there was essentially a worldwide panic on figuring out if any of the software that you're using in your organization uses the Log4j library that was vulnerable. And this highlights why it's super important to have a software bill of materials, or in short, what we call an SBOM, that lists all the components that your application or software is using. And we'll talk more about that when we reach the next section of how do we solve this problem. All right, so far we've been talking about libraries that were developed with good intention to serve a specific purpose. However, the developers didn't develop them securely, and so they unintentionally introduced vulnerabilities into the code. Now, there's a whole other type of libraries that are made specifically to serve a malicious purpose. This article came out less than a week ago, so you could see it's December 14th, 2022. warning developers that there was a flood of malicious JavaScript, Python, and .NET packages that were uploaded to package repositories in hopes that developers would download them and fall victim to this type of attack. So this is a big problem that is definitely being used by threat actors that needs to be addressed. Now, the rise in the disclosure and exploitation of vulnerabilities like the Apache Struts one, which we discussed, and the Log4j vulnerability is the reason that the use of vulnerable and outdated components was listed as the 6th most critical security risk facing web applications today. So if I remember correctly, it used to be lower. I think it was number 8 or number 10. I can't remember. But now it's the 6th most critical security risk facing web applications today. I'll stop right now. Is there a question?
There's no questions in the chat. There's comments that you're really good at explaining, and we really like your examples.
Thank you. Thanks, everyone. If you have any questions, feel free to write it in the chat, and I'll be happy to answer them. All right. So if we go, sorry, go ahead, Tanya.
No, that was it. That was all the stuff I wanted to say. You're doing great.
Awesome. All right, thank you. All right, so if we go back to the Synopsys open source security and risk analysis report that I referenced earlier, we see that like out of the 24,000, over 24,000 applications that they analyzed, they found out that 81% of them contained at least one known open source vulnerability. 80% of the applications that they analyzed were using at least one library that contained a vulnerability, and 49% of the applications were using a library that contained a high-risk vulnerability, like the Log4j or the Apache Struts vulnerability that allows an external attacker to gain remote code execution on your network. Now, that's pretty scary, because that means 50% of the applications that they analyzed were vulnerable to, were using a library that was vulnerable to remote code execution vulnerability, which is insane. So that's from a security perspective. Another thing that they did look at in the report that we're not going to spend too much time on because it's not from a security perspective, but it is still important, is licensing issues. So in some countries, like the US, creative work, which includes software that was written or code, is protected exclusively by copyright by default. And what that means is that you're not allowed to legally use, copy, distribute, or modify software without the explicit permission from the creator or author in the form of a license that grants you the right to do so. And so if the project that you're essentially using, think of it like you're taking something from GitHub, if the project that you're using does not contain a license, then by default, depending on the platform and also the country of the person that wrote the piece of code, it might be copyright protected, and that means you're not allowed to use it. And so, again, depending on your organization and the type of product that you provide, you might be introducing some form of risk or a legal risk to your organization by using that software. And so the study found that out of the 2,400 code bases that they looked at, 20% of them contained open source libraries that either had no license or had a custom license. So if it had no license, again, depending on the platform where you took the where you took the software from, or the country of the person that developed the software, you might be at risk. You might be introducing risk to your organization. And then a custom license is something that you need to review and have a legal team look at before you could use it, because a custom license could have essentially any clause in there that says you're not allowed to use their specific library. So the study also compared the different licenses that were available in each code base, and they found out that 53% of the audited code bases contained license conflicts. What that means is, for example, an organization is making use of an open source library that allows you to, let's say, freely use it, even for commercial purposes. But then they're also importing another library that has a license that says you're only allowed to use it, but not for commercial purposes. So that means there's a conflict in the licenses. Now, depending on the type of product that you're developing, the licenses might open you up again to an additional level of risk that you might want to not take in your organization. So that's from like a licensing perspective, how these open source dependencies could cause certain issues. Okay, so far we've talked about the privacy.
I have a question.
Oh, okay, go
Sorry,
ahead.
I picked the worst timing. So Ken was saying not including a license on the repo means it's not for public distribution. Can you expand on this topic?
Yeah,
So if there's no license.
Yeah, so it depends on the platform that you're using, sorry, that you're taking the library from, and also the country of the person that developed the license. So I believe I looked at GitHub, and it is not like, I can't remember correctly, so don't quote me on this, but I looked at the rules of engagement, and it is not for public distribution if the user doesn't say explicitly that it's for public distribution. I'll actually ask Tanya, do you know more on that topic?
So it depends on, like you were saying, which country. So by default, everything in Canada is copywritten. Like the moment you
Mm-hmm.
publish something, and are able to prove that you are the one who first published whatever it is, you own the copyright. And I know this because I used to write music. And so the moment your song gets played on the radio or you release an album or any sort of thing like that, you're like, that's right, I was first. Um, and it applies to code as well. So if you wrote that code not while you were working for an employer, so if you work for an employer, the work you create usually belongs to them. But it depends on if you're a contractor or a full-time employee, etc. But if you read the contract that you do, generally they own the copyright to the work that you do, but not always. And I have seen that trip people up. I don't know what the default licensing is on GitHub though.
Yeah, yeah. So US is the same as Canada by default. Software is copyrighted, and so you're not allowed to use it without the explicit permission of the person that wrote the code. So don't quote me on the GitHub thing. I read it a while ago, and I remember seeing that it wasn't meant for public distribution unless a license is included. But again, everybody do your research because I'm not sure. Does that answer the question?
It does. He says, thanks. So glad to hear that. I'll keep it in mind when publishing my repos. I think the GitHub default is no license at all, but NPM includes a default license for you.
Okay, awesome. All right, sounds
Good
good.
answer.
Thank you. Any other questions?
That is it. Mostly it's just me and Ken in the chat talking about how awesome you
Okay.
are. You can
All
read
right,
that.
thank you. All right. Okay. So far we've talked about privacy, security, and license compliance issues. We even discussed it from a functional perspective that could potentially, so the issues that could potentially come from using open source software. Now the question is, how can you avoid all these types of issues? The first thing that you absolutely need is something called a software bill of materials, or in short, an SBOM. We've touched a little bit on that when we were discussing the Log4j vulnerability, but essentially this is a list of all the open source and third-party components that an application or a piece of software is using. So think of it as the equivalent of a list of ingredients that you find on a package of food that you want to buy. So just like I might want to know the ingredients because, let's say, I have certain food sensitivities or I'm allergic to a certain type of food, I would like to know the list of ingredients in an item of food that I'm buying. In the same sense, I want to know the software bill of materials for my application or the application that I'm using so that I know exactly the risk that I'm introducing in my organization by using that certain piece of software. Now, depending on the software that you use to create this SBOM, it might include slightly different items. I have a small list of information that is usually included, and it's based on something called the Software Package Data Exchange Standard, or in short, SPDX. Now, remember, so you've got things like the package supplier, the package name, the version, whether it's a direct or indirect dependency, the creator, and so on. But essentially now remember the graph that we looked at. So when you directly pull down a dependency, those dependencies need other dependencies, and those dependencies need other dependencies, and so on. And so you end up with a huge graph of dependencies. And so this is not something that you could do manually, or you could analyze manually, just coming up with that full graph. And so this is something that you need to do automatically or in an automated fashion. And that's essentially like all the direct dependencies and all the indirect or transitive dependencies would be included in something called the SBOM. Now, it became absolutely important to have this software bill of materials, or SBOM, when we saw an increase in the exploitation of vulnerabilities in third-party software, like the Apache Struts vulnerability or the Log4j vulnerability. And so last year, it became mandatory in the US that you need to provide an SBOM, or again, a software bill of materials for software vendors contracting with the federal government, just so that the government is aware of the level of risk it's accepting when using your software. Now, I live in Canada, so we're not there yet in Canada, but it is something that I believe they're currently working on right now, and something that hopefully will happen in the near future.
Ooh, we have another question.
Yeah.
So if you're using NPM, is the package.json file produced by NPM? Would that be a good enough example of an SBOM?
I believe that only contains the direct dependencies. Isn't that correct?
I don't know. I actually don't program in NPM, but I have a feeling
Me
you're
too.
right, because the transitive dependencies are like the ones that are linked as like second layer generation and below. I can't see it being in
Exactly.
there. So
Yeah, so I also don't program in NPM, but I would imagine that would only contain your direct dependencies, and then those dependencies also pull down other dependencies. So you need a tool that actually, I think there are certain packages that you could use in NPM that will generate that SBOM for you, but I don't think they would, like specifically the package.json file would have that.
yeah, but great question. Awesome. Go on, lead us, Rana.
All right. Um, Now, again, creating this SBOM is not something that you could do manually, because it'll take forever. You'll have to, go to your config files and figure out which ones you're directly importing. And then from there, figure out, for this library, which library does it depend on? And then for that library, which library does it depend on? And then for that library, which library it depends on, and so on. And so it takes forever to do manually. And so there are tools that are called software composition analysis tools, or in short, SCA, that automate the process of generating an SBOM. And not only do they do that, they also identify known vulnerabilities in the open source dependencies, and ensure that you have license compliance when it comes to those open source dependencies. So having an SBOM is great, but if you're not doing anything about that SBOM to identify if any of the software that you're using is actually vulnerable, then essentially it's just that you're aware that you have a list of libraries, but you're not actually checking them to see if they're vulnerable. And so an SCA tool essentially comes up with that SBOM, and then it cross-references it with vulnerability databases to identify if there's any known vulnerabilities with the libraries that you're using. So essentially, these tools work in 3 steps. Again, the first one is to generate an SBOM. So that's a list of all the direct and indirect dependencies with the version numbers that you're using. The second step is it cross-references the list with vulnerability data sources. So depending on the tool that you're using, the vulnerability data sources might be different. Some tools, actually most tools use the MVD database, which stands for the National Vulnerability Database. However, you could see the commercial tools have a variety of sources. So the more sources that you have, the better, because sometimes vulnerabilities don't actually make it to as, a full-on CVE and then end up getting put in the MVD database. Instead, some of them are just put in GitHub issues or comments or through private vulnerability databases or so on. And so the more variety that you have when it comes to your vulnerability data sources, the better. Now, once you've cross-referenced the list of direct and indirect dependencies with your vulnerability data sources, if you get a hit that a specific library is known to be vulnerable to so-and-so vulnerability, then the tool will report it. And that's essentially how the tools work. Now, there's a ton of SCA tools out there. Some of them are open source, like Dependency Check, which is developed by the OWASP organization. Big shout out to OWASP and everything, for everything that they do. So that's an example of an open source one. Others are free, but not open source. So you've got NPM Audit is free. GitHub, sorry, not GitHub. What was this called? Dependabot. Dependabot. I'm like trying to remember. Okay, so Dependabot is integrated in GitHub. You could use it for free. It has its own separate issues. I think there's a webinar by Jim Monaco that talks about Dependabot and like the set of issues that come with that. But if you're not using anything, Dependabot is a great source to use until you could use a better product. And then there's other ones which are commercial, like Veracode, SNCC, and so on. Now, I don't want to endorse a specific vendor. So instead, what I'm going to do is discuss the features that you should consider when selecting an SCA tool. And then I'll leave you to, depending on your organization, what works best for you when it comes to choosing an SCA tool. So the first one, and this is the most important one, is language support. So NPM Audit can identify vulnerable NPM libraries. It can be used to identify vulnerable Ruby libraries. Same goes with, again, Dependabot. One of the issues that Jim Monaco talks about is that although it says it has support for many programming languages, it was mainly developed by JavaScript developers, and so it covers JS libraries really well. But when it comes to other languages, it does a mediocre job at best. And so it's really important to make sure that the SCA tool that you're using actually covers the languages that are used by your organization. Now, the second one, and we touched upon this, is the vulnerability data sources that the tool references. So again, the more diverse the vulnerability data sources, the more coverage that you're going to get. Not everything is assigned a CVE rating. And again, ends up getting logged in the National Vulnerability Database. Some of them are reported through commit logs, issue trackers, social media, private vulnerability databases, and so on. And so the more diverse the vulnerability data sources, the more coverage you're going to get. The third one is accuracy. So the tool's ability to identify if your application is using a vulnerable function. So it turns out just because you're using a vulnerable component doesn't necessarily mean that you're vulnerable. You have to actually be calling the vulnerable function or using the vulnerable function in order for you to be vulnerable. And I remember reading this somewhere. I can't remember the statistics source. If anyone has it, feel free to put it in the chat, but the statistics had shown that 90% of the time, you're not actually vulnerable when you're importing a vulnerable library because you're not using the vulnerable function. Now, that doesn't mean that, oh, the risk is so low, no, and that you shouldn't update. If you're not using the vulnerable function, you should definitely update, because just because today, you as a developer are not using the vulnerable function of an outdated library, doesn't mean that tomorrow a new developer is going to join the team, or you might forget and you might accidentally import, you might accidentally use the vulnerable function. And so you should definitely update, but the accuracy feature, which is only available with actually very few commercial tools, comes in handy when it comes to, I guess, evaluating the risk of which one you want to update first. So prioritizing which one you want to update first. Because if I'm actually using the vulnerable function, then I definitely want to update those first. And then when those are updated, then I'm going to start updating the ones where I'm not actually using the vulnerable function. So it does come in handy, but it's difficult to do because you would have to compare software composition analysis with static code analysis as well. All right, the fourth one is remediation capability. So some SCA tools have the ability to auto-generate pull requests and update to a non-vulnerable version. However, that does come with its own risks of breaking the bill when you update, and so something that you might want to do in a test environment first before it gets pushed into prod. The fifth one is configuration and integration. So the tool's ability to be configured to, let's say, pull from different vulnerability sources or be integrated in your pipeline and so on. And then the last one is reporting. This one is self-explanatory, and so I'm not going to spend much time on it. It depends on what is important for you in your organization and how you want that information to be presented. So depending on that, that might affect the certain tool that you end up selecting for your organization. All right, so like I said, I'm not going to endorse a specific vendor, but what I'll say is from my personal experience, you get what you paid for when it comes to SCA tools. It's great to start with open source or free SCA tools, but then at some point you realize the limitations of those tools, and then you might want to move to commercial tools that provide more of the features that we just discussed. All right, so we're almost done the presentation, but I didn't want to end it without showing you an example of an SCA tool and showing you how easy it could be to run the SCA tool. So OWASP Juice Shop, so this right over here, is an open source intentionally vulnerable application that is developed again by the OWASP organization, and it's written in Node.js. And so the tool that I'm going to use to see if it's using any vulnerable dependencies is npm audit. And you'll see over here how easy it is to actually run this tool. It takes a couple of seconds, maybe minutes if it's the first time that you run it, and it'll report the vulnerable dependencies. I'm just going to click play. And you could see over here, I'm just running it in the root repository of OWASP Juice Shop. And then it just takes a couple of seconds to run. And here we go. You could see there's 76 vulnerabilities, 67 of them are low, 5 moderate, 2 high, and 2 critical. And you can see over here, it says it scanned 23,905 packages. So that's how many dependencies this small intentionally vulnerable application was using. So it highlights how you can't do this manually. You definitely need an automated tool to do this. And you could see it gives you the information of each vulnerability. The verification bypass one, they're actually using the vulnerable function. And so you could really exploit this vulnerability. And it essentially allows you to completely bypass authentication as an unauthenticated attacker. And all it took was essentially just running npm audit in the root directory of the repository. That's how easy it is to get started with SCA tools. All right. So this concludes our presentation. Now, before I end, I wanted to circle back to the 3 questions that I said we'll answer during the presentation. So the first one was, what are open source dependencies? So we said that open source dependencies are open source software that an application uses. They come in 2 forms. The first one is direct dependencies, which you directly import in your code, and indirect or transitive dependencies, which your direct dependencies depend on. The second question that we asked was, why should open source dependencies be managed? We looked at real world incidents and statistics from the open source security and risk analysis report that was done by Synopsys to understand that open source dependencies need to be managed for the purpose of privacy, security, and license compliance. And then the third question that we asked was, how can these dependencies be managed and secured? For that, we talked about software composition analysis tools, or in short, SCA tools, that automate the process of generating an SBOM and identifying vulnerabilities in open source dependencies and identifying licensing issues. We also talked about the different features that you could consider when selecting an SCA tool. And that is it. Thank you for taking the time to listen to my presentation. I hope that was useful. Wow, that took a full hour. I did not realize that. It felt like it was like 15 minutes.
You were great, and we have a few questions. So I just put all of your links into the chat so people can just click them if they want to. But if you're watching this later, we will post it in the YouTube video comments underneath the video. So if you're like, oh, I don't want to type that out, don't worry, we got you. Okay, so there's 2 questions. One is, do you have any thoughts on NPM audit versus NPM outdated? I would run both, but do you have any thoughts on it?
I'm only familiar with NPM audit. I'm not familiar with NPM outdated, so I can't comment on that.
I think it just tells you if stuff's old. I find whenever I get to NPM, I make a mess. Like it's like, oh, you ran this, you should run that. I'm like, should I?
Yeah, so if it tells you like if things are old, so NPM audit tells you if things are vulnerable. If NPM outdated tells you if things are old, then I agree with Tanya, you should run both, because just because it's outdated doesn't mean that you aren't introducing a level of risk in the future by using an outdated and unsupported piece of software. So run both and then update everything.
Yeah. Oh, I like it. I have a friend that works on SCA tool, and I won't explain which one because we're being vendor neutral, but he was saying it's like having a ticking time bomb in your app. Even if it's not exploitable, if you have something where it's a really big vulnerability, you still want to put it in the backlog and fix it.
Absolutely.
Okay, so Camilla asks, when updating dependencies, I see some people focusing on updating just the production dependencies. Do the dev dependencies offer big risks as well, or is it okay to prioritize production dependencies over dev?
It is definitely okay to prioritize production dependencies because that's what's external, and that's what it's being used by the client. And most of the time, that's what has PII information in it, or confidential information in it. However, that doesn't mean that you shouldn't update development, your development environment or your test environment or so on. I worked as a pen tester before I started working as an application security engineer. And so for some of our use cases is we acted as an internal threat vector. And so we were given access to the network. And then from there, we had a certain goal to reach another part of the network or another network that the organization was using. And the way we did that was essentially look for vulnerable servers in those networks in order to see if they're exploitable, and then maybe they could give us remote code execution to to a server that is within the network that we want to reach. So definitely something that can be used by an internal attacker. Now, if your dev environment is also public, then that should be updated right away as well.
I have to say, like, I think that if you're gonna do testing, you would want to test in dev or a lower, like, I mean, if it's an emergency, maybe you're gonna run off and do prod because you're working at Equifax and it's 2016. But like, I definitely want dev and QA and UAT to mirror prod so I can get good tests, right? Because like, what if you update it and then you broke everything? You're gonna be unpopular, to say the least.
That's a great point. It's actually quite conventional to start with prod and update prod before trying it out first in test, because like updating libraries does sometimes break builds. And so it's important to update them in the lower environments, make sure they don't actually break anything in the code, and then replicate that in prod. That's a great point, Tanya. I was thinking just security perspective.
It depends on how scary it is. Like I worked somewhere once and we were so scared, we turned off our servers. Like we had this big meeting and everyone was freaking out. And I was like, we do have the option to just turn them off like overnight or for a day until we fix everything. And yeah, we looked dumb briefly, but they were just so worried about the thing that we had going on. And yeah, this might sound nuts, but we just turned them off, patched, tested overnight, and then in the morning turn them back on. And we're like, well, we serve Canadians. Hopefully most of them are in bed.
Yeah, and that makes sense. Sometimes it's a good enough reason to act like the vulnerability is a good enough reason to turn off your servers.
Yeah. Oh my gosh, that was great. Does anyone have any more questions from Rana? And also, I hope you clicked all the links I put and followed her on everything. She's also on Mastodon too. I figured that out during the call.
No, I'm not.
You're not?
No, I'm not.
Okay, so a thing that some Mastodon servers have been doing, so it was the one that says bird site.
Okay.
So there's one Mastodon server where they've followed a lot of people that are just really cool on Twitter, and they're taking your tweets and sharing them onto Mastodon. So people can follow your Twitter tweets on Mastodon.
Okay, interesting.
So
I should
you
get
are
on that platform.
there. Well, you're cordially invited to the infosec.exchange server, which is where all of the security nerds are hanging out. I was like, why isn't she on infosec exchange? And
Yeah,
that's why it's not you.
I never got around to it. But yeah, no, definitely something that I want to join because everyone is moving to that platform. I'll of course continue Twitter until it completely breaks down, but I definitely will be on Mastodon as well, hopefully in the near future.
For sure. Okay, everyone, this is literally your last chance until you see Rana at another event. Ken.
This was so awesome. Thank you so much.
No problem. Thank you for attending.
Happy to be here.
Do you have a question, Ken?
I've been able to give all mine, so thank you for that.
Awesome. Awesome. There's a whole bunch of comments in the chat saying thank you, and it was great, and it was so helpful. Yes. Thank you so much for being on our show, Rana.
No problem. Thank you so much for having me. I'm so happy I'm finally on the We Hack Purple show.
I know. Well, just to be clear, you can come on again whenever you want.
Absolutely. When I prepare a new presentation, you'll be the first person to contact about that.
Awesome. Okay, everyone, since I got all the questions and lots and lots and lots of thank yous, we are going to shut down for now. If you celebrate Hanukkah, if you celebrate Christmas, if you celebrate New Year's, if you celebrate literally anything, I hope you have a wonderful time. Thank you so much, Rana. Thank you, Amanda, for organizing me so I show up on time and do all the things I'm supposed to do. And thank you, We Hack Purple community. I really appreciate you coming, and I know a lot more of our community is going to watch this when we release it to YouTube. I will definitely send a message in the community so everyone can see. And that's it. That's all I got. Thank you very much.
Thank you for having me, and happy holidays, everyone.